thank you for attending my talk. We are going to talk about migrating from bare metal machines to AWS ECS, a real-world scenario. As soon as this works. Come on. Yeah. Okay, need to click. First a few words about myself. My name is Sebastian Struß. I've been working with Golang for about a year and with PHP for about 20 years. For about 10 years, sorry. And I'm a technology enthusiast since about 20 years. And this is my first talk. So let's first see what we are going to talk about. First, we are going to talk about the motivation, why we needed the change to AWS ECS instead of just using bare metal machines. Then we're going to talk about how the stack looked before, how we changed it in our development environment from Vagrant to Docker, then the containerization from our bare metal machines to AWS ECS. Then we're going to talk about the changes in the application and its configuration, the changes in our deployment strategy, and the pitfalls when starting to use AWS ECS. And of course, soll ich den abnehmen?
Ja.
And in the end, we're going to talk about what's our next steps. And after all, we are going to have a QA where you can ask any questions you like. So, motivation, why did we need it? First of all, we want to get more flexible and have a better performance when scaling. Because in the first place, when we had EC2 instances on bare metal, we had the issue we needed to spin up a new machine, then deploy some web server on it, get the configuration copy, deploy the application itself, and get everything set up. So that's where AWS ECS is a bit better, because we can just spawn containers and be good, or spawn instances, then spawn containers. And next thing is making the ecosystem easier deployable. That's actually what I already mentioned. So why we needed it is our requirements change over time. Everyone knows you develop a feature today, works great, and then in the end, with increasing user rate, you see, okay, this doesn't perform anymore, so we need to scale. Then next point is load increase. Our performance need to be improved if our features don't perform well, and expected huge user count increase. So also need more performance, need more scalability. This is how our stack looked before the migration. We have a document storage on multiple bare metal machines. Then we have a message broker also on multiple machines. We have a log transformer. We have bare metal machines for our API that contain a web server, the application itself, a key value storage, and also we use some of our AWS hosted services. Not all are listed. This is how our development environment looked like. We had everything in one big vagrant box. Not very optimal if you want to reflect something, how it looks in production. So we changed that to Docker with Compose and have every component in its own container. So it looks much more like an AWS ECS and in combination with the AWS services. This is an example of how our Docker Compose file looks like. So we have an HA proxy, which is kind of like a load balancer in AWS ECS, because you're not directly talking to the API in production as well. Then we have our Nginx. We have our PHP AppLike backend. We have the document storage, a log transformer, and the message broker, and a local stack to emulate our AWS services that we use in the cloud. As you can see, we are using the build property there to build a context, because we want to put our custom Nginx configuration in that container, and also we want to fix some permission issues we had by setting a UID and JID with fixed UID. Yeah. So this is how it in the end looked like after going the ECS way. We have an ECS cluster which hosts our API and the worker nodes, and all of them are coupled in tasks, which are for API and worker and scheduler, of course, which contain a web server, at least for the API, the application, and the key value storage. All of the other services we left untouched for now, because our first goal was to have the application itself be scalable. Changes to the application were basically minimal. We just added the .env component for Symfony, so we are able to read environment parameters as configuration instead of having everything in the parameters YAML. So we are actually more modular with that and can deploy the same image in every environment and do not store any configuration or secrets in our parameters YAML by just reading it from the environment. Another positive thing there is we can tell it how to parse a value. So we can say, okay, the debug toolbar, that's a bool, either true or false. And we can also say, okay, interpret the input as JSON, and then we can have our array or object there to reuse it. Next are the changes to the deployment strategy, where we do not need to use automation tools anymore, which we had before, where we actually always deployed our Nginx, its configuration, PHP and its configuration, and the application itself. Instead of that, we use our pre-built containers that we can use for every environment. And another change is the use of AWS ECS that enables us to use the AWS SSM parameter store. That's where you can store every configuration and every secret that you have for your application, and just tell it, okay, use the space path, and then it will download it and put it into your environment. So your application can use it in combination with .env. The next change was to use ECS deploy, another handy tool. Both of them, by the way, are available on GitHub. ECS deploy is good for, well, deploying, obviously. It changes your service and your task definition to use the new build container. And you can use it also for rolling back if something went wrong, and you can specify a timeout to say, okay, if it takes longer than this, it doesn't work. Next thing is rolling upgrades and downgrades. Maybe some of you or many of you have already experienced that. We didn't use it before, but using ECS deploy, we are then able to do that, or using AWS ECS. Next thing is pitfalls. So with the container replacement strategy, you always want to ensure that your API is not hosted on the same machine as like a worker also, because they can be I/O. They can have heavy I/O usage or heavy CPU usage or memory usage. All of them you don't want to have as a limit on your APIs because they respond slower then. Yeah. Next is EC2 instances and resource limits. As already mentioned, you don't want to use your resources to the max, because if you do, then you're going to have trouble with your API. Then minimum and maximum healthy percentage. There we had a funny issue in the beginning when we brought our sandbox up. We had issues deploying our stuff because we had only one API as a desired count, and our minimum and maximum healthy at 100%. So yeah, it's not deployable. But in the end, AWS actually fixed that, and now the GUI says, hey, by the way, if you do that, you won't be able to deploy. So when you only have a desired count of 1, you also have to take into consideration either setting the minimum to 0 or the maximum greater than 100 or greater than 200. Next is PHP applications with frameworks. They can be slow. Warming up the caches can take quite a bit of time, depending on the size of your application. We did that while deploying, and still, for some reason, the first requests on the API were a bit slow. So the health check did also take quite a bit of time. And yeah, if that takes long, then also your service doesn't go in service fast. So you have to take that into consideration. Another thing is ECS can be slow. When using Docker, maybe many of you know already, you shouldn't build like large images where you have huge dependencies inside. So you have to take into consideration whenever you deploy something, it needs to get downloaded from ECR, which is the or the Docker repository for ECS. And yeah. Next thing are cron tasks and their runtimes. As already said, with the PHP applications, it can be slow, and there are also some strange issues we encountered when using AWS ECS regarding cron tasks. They usually run for us 5 minutes on bare metal, and on ECS we have strange issues with like 7 minutes or so. In the end, we fixed that with locking here and there, and somehow it did then work, but yeah. Next thing is ECR lifecycle policies. When pushing images to ECR, you quite fast get into the account limit, which is, I think, 4,000 images, well, 4,000 tags per image. So say you have an application image, push 10 times a day, a few developers, then you reach the limit quite fast. So you need a lifecycle policy to delete your images when unused, like say we want to delete images that are untagged after a day or so. And let's say we want to delete sandbox images that are older than 10 days or like less than, more than 10 days old, yeah. Next thing is our next steps. So we want to change our app to use a microservice pattern because before we had a big monolith application that we tried to separate. We are trying to do this by using Golang as a kind of replacement for PHP parts that were slow and try to gain some performance there. Another thing is we want to use more cloud services because we want to be able to adopt new features faster and have less administrative overhead because you don't want to manage that Elasticsearch cluster, for example, when there's a node failing or so. Yeah, and we are hiring. We are hiring smart people if anyone is interested. Please come to me after the talk or just apply at Jobs AppLike info and refer to this conference. And last slide. It was already quite fast. Are there any questions? Yes, please.
How did you handle passing environment parameters to PHP FPM?
We do that by using AWS ECS, and we just call it in our container startup script with a specific path that we also preset in the task definition. So we say in the task definition, hey, pass this as an environment parameter, that is AWS ECS path, where you say /company /something /application or so, and then it downloads everything from that path, and it also sets it if you evaluate the output of the command.
That's basically evaluating the environment file or sourcing the file manually from wherever it is.
Yeah,
PHP FPM for security reasons doesn't pass the environment downwards to the workers. So
no.
You have to either change the Nginx script to load something via Lua, or parse the file yourself and add it in CGI parameters. And both of these approaches seem like they're more rigid than just deploying the file in that environment and expecting it to just work. And that's where I got stuck, trying to migrate to Symfony 4.
I'm not 100% sure how our current configuration looks like, but I can tell you that our application knows about the environment parameters, because otherwise it wouldn't be able to work. So I would have to look that up. Are there any other questions? No? Yeah.
Sure. When moving from one monolithic application to the microservices in the cloud, how did you go about it? Did you did you do it incrementally, like phasing out parts of the and did that integrated well with the between the still existing application and the part you moved into the cloud, or did you face any problems there?
We didn't have many problems there. We have several parts of our application that were already kind of separated, and they both share a common code. But in the end, we didn't have much issues because we already used message queues and stuff to have them kind of separated. So we already followed a program pattern to be able to do that.
Okay, so no noteworthy performance issues when talking between the existing systems and the cloud?
No, not really. Yes, please.
How do you structure your containers? I expect you have a PHP application.
Yeah.
So you probably have some PHP FPM running there.
Yeah.
And maybe some web server, I think Nginx.
That's
how
right.
Do you combine it?
What do you mean? They run on the same network, and the Nginx has an upstream configuration for the FPM. Maybe I got your question wrong.
Normally, you want to separate all the processes in each our container.
Yeah.
What are your containers now? You have some container for Nginx and one container for
It's exactly like you described it. We have a PHP FPM container and an Nginx container, and the FPM container exposes the 9000 port for FPM, and then the Nginx can forward to that port, forward the request to the port.
And how do you manage static files there, for example, like images?
They are in both containers, so it's basically copied. Yes, please?
How much time did it take to separate monoliths to microservices, and how many people did work on that?
We are not yet really done on that. It's still in progress. We are working on that for longer.
Longer, more precisely?
Longer than a year, I think. But we were not like non-stop working on that, but rather do it step by step and have new features implemented meanwhile. And we have.
You break immediately database too, or you use the same database and then
currently we use the same database, but we already have approaches for separation where we have several databases which then communicate, or where
it's
changes.
Recommended, right?
Yeah, where changes are communicated via AWS SNS and SQS.
How deep did you go with separation of domains? Because I think that's the most difficult thing, breaking the monolith.
I'm not sure how to answer on that. Sorry.
Was it difficult to define domain of these microservices in your team?
No, not really. It was done by the leads. Any other questions? No. Okay. Then I'm done.